When you give us a call, our team is ready to discuss any application that you might have. Some of the most common things that you might need to know is how big is the thing that you're heating? Is it a tank? Is it a reservoir? Is it a pipe? What are you trying to heat? The next thing is, how fast do you want to heat it up? Do you want to do it in a couple of hours? Do you want to do it in 5 minutes? Another thing that's really important to know is the voltage. Do you have 120 volt single phase or do you have 480 volt three phase? Having that power available is really important, and your facility has to be able to accommodate this heater once it's installed. Another thing is, tell us a little bit about your application and what you're trying to accomplish. When you're designing a process heater, we need to know the process ranges, what pressures are there, what temperatures need to be gotten to, what are the bad temperatures and what are the good temperatures. Overall, what can you tell us about your process so we can know for sure that we designed the right heater for the right application? Electric process heaters are mechanical in nature. They do run on electricity, but for the most part, they bear pressure and they go to high and low temperatures. So there's a lot of things that can go wrong with them. How do you tell if your heater needs to be replaced? A couple of things that are really obvious is, number one, if the performance reduces when power is applied, you know that you've lost heating elements or the ability to create heat, or maybe you've lost some heating elements. Heating elements, like any mechanical device, lose about 5% of their performance every 5 years. Sometimes when other things come into play, they'll go faster or slower. I've seen electric heaters in process for over 30 years, but I've seen some that have gone out in 1 year. Electric process heaters can get attacked by corrosives because the heating element itself is the hottest portion of the process. The hottest portion is always the part that gets attacked first. So corrosion is a big issue with electric heaters, and you can't always see corrosion in electric process heaters. It occurs inside of the process. So a great preventative maintenance program over time where you pull that heater out of process and actually take a look at it, is going to help you understand if you've lost elements or if you're having any corrosion issues. In 25 years, I've seen a lot of funny things. Electric heaters don't like water. And one example is, I had a customer who had a lot of very large 365 kilowatt circulation heaters vertically installed. So the terminal box was on top. Well, while these units were being stored in the yard, they left them in the open air and the terminal boxes were taken off and they filled with water as rainstorms came through the winter. When springtime came and they decided to install these in the process, they rolled the terminal box over and bolted them shut. So when commissioning time came, they didn't work. Inside of a heating element is a product called magnesium oxide. It doesn't like water, and with about 6 inches of water sitting on top of those elements, it just absorbed all of them in there. So then when they went to turn the heaters on, they didn't work because they were all shorted out. Electric process heaters are installed in your process, so it's really important that they run really well over a long period of time. And just like with your own car, you got to have a good preventative maintenance program for your heaters. A good preventative maintenance program would include several things. First of all, it would include that you check that each circuit in your electric heater is pulling the proper amperage from when it was built brand new. Again, a 100 kilowatt electric circulation heater, for example, should pull a grand total on 480 volts three phase of about 120 amps. If you ask for full power and you only see 80 amps, you know you've lost some heating elements, so you need to go check them. Electric heating elements also have resistance to ground. That is, that there's a resistor suspended in the middle of a heating element. When that resistor actually touches the inside of the heating element, it'll short out. There's a way you can check to see if your heating element has potential to ground. It's called a megger. Meg-ohm resistance check is taking a meter that can go from about 1,000 to 5,000 volts DC. You apply it to the heating elements and you crank it up and you can see if you've got resistance to ground. In other words, megging your heating elements is probably one of the best ways to really check your heater to make sure that it's not going to short out on you. Corrosion is another thing that occurs in electric process heaters. Because you're heating chemicals or there's product around that can corrode the heating elements, it's really important to pull that heater out. Realize that the electric heating element is the hottest part of the process. So the hottest part always gets attacked first. What you want to look for is stitching or some sort of a corrosion or a white corrosion or a thinning of the element. That can cause a short to ground on the electric heaters also. So be careful to look for signs of corrosion on your electric heating elements inside of your process. That means you have to pull the heater out of the process. So part of your preventive maintenance program should include that you pull the heater out of the process and get a good physical look at it. Electric process heaters come in a variety of sizes and shapes. They're in your facilities, and your preventative maintenance programs will sometimes require you to evaluate or replace your electric heaters. Powerblanket offers a complete thermal solution from the temperature controller to the relay to the heater itself and the temperature sensor. When you're looking for a solution to replace the heater or for a new application, give us a call. Powerblanket offers complete thermal solutions, and when it comes to process heating, Powerblanket has you covered.